Hello friends, my name is Mayank Chugh and welcome to my YouTube channel. Today we are building a domain specific AI assistant end to end, a finance FAQ assistant by fine tuning Qwen 2.5 model with Unsloth through all three real stages: non-instruction fine tuning, instruction fine tuning, and DPO preference alignment. All of it on a single free Colab T4 GPU. This is not a tutorial with clean cherry picked result. I am going to show you the real training losses and the real model answers, including a place where the model actually got worse, not better. That's the honest picture of what fine tuning a 500 million parameter model on a few dozen example actually looks like. T4 GPU runtime. So let's go. What are we building? The assignment: build a domain specific AI assistant for one business domain. I picked finance FAQ, saving account, loans, credit cards, mutual funds, insurance, tax. Here is the analogy. I'll keep coming back to training this model is like training a brand new bank teller in three stages. First, they read the textbooks to pick up vocabulary. Then they shadow trained staff answering real customer questions. Then they get coached on which of two people answers a customers would actually prefer. So before we touching any training code, I tested the raw base model on our 10 evaluation caution. These are real output, not paraphrased. Ask it, what is SIP? A basic finance term, and it says I am sorry, but I cannot assist with that. Ask it how to apply for a personal loan, and it opens with I am sorry, but as an AI language model, I am not able to provide specific guidance. Then gives three generic bullet points that could apply to literally any financial product. So this is our baseline. Everything from here is trying to fix this. Here is a full pipeline: base model, then three LoRa adapter chained one after another. Stage 1, non-instruction fine tuning on a raw paragraphs. Stage 2, instruction fine tuning on Q&A pairs. Stage 3, DPO on preference pairs. One engineering detail that actually bit us during recording. Each notebook runs in its own fresh Colab session. So the adapter from the previous stage has to be reloaded every time our first attempt at the DPO notebook crashed because we forgot to re-upload the SFT adapter. To fix, push every adapter to the Hugging Face hub. at the end of each notebook and download it at the start of the next one. Much more reliable than manual zip upload. However, we'll also doing the same thing while doing the zip as well and downloading. Why can this run on a free T4 with only 16 GB of VRAM? Because we are not touching all 500 million parameters. That's huge. LoRa freezes the base model and only trains small low rank matrices bolted on to the attention and MLP layers. The real numbers from our run 8.8 million trainable parameters out of 502.8 million total. That's 1.75%. And we load the frozen base weighted in 4 bits. That's the QLoRA part, which is what makes the memory footprint small enough for a free GPU. Same LoRa config across all three stages: rank 16, alpha 16, dropout 0.05. Actual deep dive. Let's put actual numbers behind each stage of the analogy. Stage 1, the teller reads the textbooks, 57 raw finance paragraph, no question, no answers, just domain language. Stage 2, the teller shadows train staff 104 real instruction response pair, teaching the actual behavior of answering a question. Stage 3, the teller get gets coached by preference 51 pairs, where we show the model a good answer and a bad answer to the same question and nudge it toward the better ones. That's DPO, direct preference optimization. If you like my videos and if you really want me to create more videos like this, and you really appreciate my work, then please like, share and subscribe. I have seen that people are looking it but not sharing it, not subscribing it. So it will help me and motivate me a lot if you will like it and subscribe it and share it. So those who need it and it could help to others, please share it. Let's come to the next slide. Real answers. Here is the same question through all three model word for word from the actual notebook output. Base model refuses outright, I'm sorry, but I cannot assist with that. SFT nails it systematically. Investment plan: invest a fixed amount at regular interval. Correct definition. DPOs, the stage that's supposed to be the final polish, actually gets it wrong. It calls SIP a simple account payment, a prepaid bill for things like water and electricity. That's a hallucination, and it's worse than what SFT produce. This is exactly the kind of honest finding I don't want to hide from you. DPO with only 51 preference pairs and 3 epochs on a 500 million parameter model does not guarantee improvement on every question. It is a real risk of preference fine tuning at this scale. And I'll explain why in a minute. Numbers. Here's our every stage real training numbers side by side. Notice the loss actually goes up slightly from stage 1 to stage 2, from 2.0659 to 2.0564, barely moves, and that's expected because stage 2 is much harder task producing. Fully structured answers, not just continuing raw text. Stage 3 losses loss of 0.2995 looks dramatically lower, but don't be fooled. DPO uses the completely different loss function, a preference loss, not cross entropy. So it's not an apple to apple comparison with the first two numbers. And here is the pattern I want you to actually learn from, not just watch every single stage producer or correct first sentence and then degenerates into the repeated repeated garbage or hallucination follow up questions. That's not random bad luck. That's not the random bad luck. It's greedy. Decode with no repetition penalty on a tiny model trained for multiple epoch on a tiny datasets. Textbooks overfitting plus no repeating guard. I'll show you exactly where in the generation call this happen. Again, please, if you like my videos, please like, share and subscribe. Now final key takeaways. One LoRa lets us train just 1.75 of the parameters, which is exactly why this fits on a free T4 GPU. 2. The three stages teach three different things vocabularies, then answering behavior, then preference between answers. 3. Healthy looking loss numbers don't guarantee clean generation. Every stage degenerate after one correct sentence. 4. DPO is not automatically better. It introduces a real regression on the SIP question. 5. Chain your adapter through the Hugging Face hub, not manual re-uploads, or you will hit the exact runtime error we hit. Full notebook datasets and adapters on GitHub link I'll put in the description. So let's move to the code. Thank you. So this is our first notebook for stage 1 non-instruction fine tuning. So first thing we have to ensure we should connect with T4 GPU and we should have all the required tokens. Hugging Face token, actually Hugging Face right token should be there in your secrets in the Google Colab. Third, once it connects, you should upload the data. Here we are using non-instructional text data. Let me upload. We have to create a folder. That folder name is data. Inside it, I'll push my file. File name is non-instruction text field. If you want to see this file, uh, this file is about the text file about completely about bank account related and bank credit card, debit card, finance related book text. So let me go back. So as we said, think of a brilliant new hire who never worked in a bank before. They answer customer query. We make them read finance textbooks cover to cover. That's exactly what this notebook does, but for a language model. So in that non-instructional, our textbook, this one, if you see, that is around 57 raw finance paragraphs are there. No question, no answer, just plain text. Finance vocabulary like EMI, SIP, NAV, TDS, QLoRA, collateral, how concepts relate, credit utilized, and all these things are there. Loan approval, debit card related information is there in that text. So as we told, we are using Qwen 2.5 pre-trained on a general internet text. So we are here currently, and first stage is non-instruction fine-tuning. 57 raw finance paragraph method. Next, token prediction. No Q&A format. Domain vocabulary and writing skills, writing style. Finance stage adapter. That will be the final file which will be saved, and this will be the final outcome of this one, first one. Second one, basically instruction fine tuning, SFT. Here we will have a 104 questions, 104 questions answers pair. SFT trainer, we will use Qwen, this Qwen 2.5 chat templates. Go learn to answer finance questions. Finance SFT adapter, that will be the file saved. That will be the final for the stage 2. The third stage, we will use DPO preference alignment. Data will have a 51 chosen rejected pairs. DPO trainer beta 0.1 1R5E-6. Goal, prefer complete safe professional answers. The outcome for this is finance DPO adapter. Now let me explain you the architecture in an architecture format. What is actually the cycle pipeline look like? So we will have base model Qwen 2.5. We will feed 57 raw finance paragraphs, non-instruction data .txt file. We'll use LoRA R16 alpha 16 dropout 0.5 SFT trainer plain casual LM objective. We'll have a loss because I have already executed. We'll have a loss of 0.2.0.6, this one. We'll have this for the evaluation purpose. We'll have this 10 questions asked every stage to see the updates. This notebooks will download the every stage model to your local, as well as it will push to Hugging Face. Stage 2 will have 104 instruction purpose, instruction dataset.json file. Continue LoRA from stage 1. 5 epoch, 35 steps will be there. Loss. Similarly, again that at the end we will test with the 10 evaluation questions. This stage also will save a file of an SFT adapter. This is the model for the second stage. In this stage also we will push the model to Hugging Face, as well as we will download it in the local. So a snapshot will be downloaded. So in this stage as well, stage 2, while it is taking that model, it will first check that model is there in the Hugging Face or not. If not, then it will take from the local. So we will do accordingly, same as for the third stage. If there is any issues of push or pull, that will be fixed at during the time itself while we will run the notebook. So this stage also, as we told, 51 is choose and rejected pairs preference data set. This is the file, JSON file, and DPO trainer will be there, and loss will be less. So you can see the loss is reducing drastically. And the final one also we will push to our Hugging Face as well in our local. And finally we will test with the final questions and answers, and we'll have the answers. So that's all about the architecture. So first cell is basically, as we told, let me make it a big. It is not coming well. Now I think it should be fine. So we have a base model, Qwen 2.5 loading 4-bit QLoRA, which cuts base model VRAM from 1 GB to 0.3. Fine tuning method LoRA, only 1.75% of weights trained save 98% memory. Trained speed Unsloth. Why Unsloth? Because it's faster than vanilla Hugging Face on the same GPU. Trainer we will use SFT trainer, ready-made casual language model training loop. The file save will be around 33 MB of first model, which will push. So we have to ensure we are connected to training T4 and our instructions files is uploaded. These are the first major versions which we have to install for the Unsloth. So we'll install Unsloth package, Xformer, TRL, PEFT, escalator and bits and bytes, data set, sentence piece. So each what it's doing is we have it here. Let me do it. I think these things you can read it later. I'll push this all in my GitHub account. So it will take some time. We're importing torch. First it is upgrading the pip, and then Unsloth, Xformer, trail, PIFT, escalator, bits and bytes, dataset, sentence piece. So these all will install. Once this is installed, then we have our non-instructions data. So loaded 57 paragraphs. A saving account is a deposit. This is the whole text of first line. Now we have to clean and chunk the text. Cleaning, basically there are some noise, there are some ASCII characters, there are some spaces, tabs, new lines, which is we don't need it. So it will reduce the size of and remove the noise. So we'll have 57 paragraphs, and we have a spaces there if you have noticed. So final chunk will be come out 57. All paragraphs pass 15 words filter, so count stay is 15. So we are using a regex for this. RE stand for regex package. Our data has been cleaned and filtered. So now we are just loading our base model with Unsloth. It's a max sequence length 512 maximum token. The model sees the at once during training. D type non auto T4 auto supports F16 float 16 Unsloth auto select load in 4 bits true. Let me execute this one. If you are not using Unsloth or any Hugging Face model, it will take a hell lot of time. At least you can see that it's a double X fast, 2x faster than the normal Hugging Face. We have to grant the access for the Hugging Face. Let's complete. Still running. Complete it. Now we will have to apply LoRA adapter. These are the parameters: R rank, LoRA alpha, LoRA dropout, biasness, use gradient checkpoints, and random state. Now we are building a training dataset. Now we have to configure SFT trainer. These are the parameters we are setting up. While I share with you, you please go ahead and read all these parameters. Why gradient accumulation? T4 can't fit 16 sample in VRAM at once. Instead, process 4 accumulate gradient, process 4 more accumulate multiply by 4x, 4 update weights. The math is identical to a batch of 16, but memory usage is that of a batch of 4. So this is all parameters applied. It will tokenization is happening of our all 57. So now we'll have to run the training. We'll run the training here. So we'll have a 3 epoch in that. First epoch loss is 2.26, second one is 1.9, and final is 2.07. Same output will come because I have already executed before. So we have 1.99, 1.99 and 2.26. This is what we are getting it. And the final one is basically, if you will take the average, it will come around 2.07. So now we have to save this first stage data. Now I am going to download this data, final this one. If you see here, we have the finance stage 1 adapter data is here. Now with this code, it will download in my local. So the download has been started. At the same time, I need to push this to Hugging Face. If you will not want to push it Hugging Face, you can skip this. However, you need a Hugging Face token with right access. I put this and enter and verify that my token has been accepted or not. It's accepted. Now while pushing, this is the code. I'm putting this as finance stage 1 adapter. Hugging Face profile, and inside it, if you will find, I don't have any models with the one what we have just configured finally. Now I'll push it and I'll show you is it there, how it comes here. So let me push this in finance stage 1 adapter. I pushed it. It is showing that this is the path, finance stage 1 adapter. Now go back to Hugging Face and check model exists or not. So you can see my adapter, finance stage 1 adapter Hugging Face model is there now, and you can see the all configurations and other files, how to use this model, copy to your bucket. Let me go back to notebook. Now we have to test this model. We'll ask few question. A fixed deposit is the interest free period on credit card. To improve your credit card score, you should uh, SIP allows an investor. So let me execute this. SIP allows an investor to purchase of a company. We can see that answer. You can save this notebook. So during the installation of this Unsloth, it is connecting, disconnecting again and again. So once now it is done disconnecting. The good thing is, even if I'll trying to connect, it is while installing, it is reconnected, connected, disconnected, and reconnecting by itself. And good thing is that there is no need for me to download or upload the data again. It is already there. Now it's all done. I have to execute the next cell, where basically I am downloading the Unsloth. There's Qwen 2.55 billion instruct model. We can see that files has been downloading. I refreshed it and it is, I can see that files are downloaded. Unsloth model has been downloaded. Fast downloading enabled. Okay, still downloading. Once that complete, now this is completely done. If I'll go refresh, I can see the Hugging Face tokenizer and Unsloth. Both are here. Let me close this one and run the base model for all 10 questions. If we have a CUDA, it will also configure the CUDA. What to expect from this base model? Vague, generic answers. Contact your bank, consult your finance advisor. Like this kind of answers will be there. I'm sorry. We are getting. I'm sorry. What happened if? Oh, 1 second. Oh, let me. What is the legal credit? Okay, it is still dull. I'm not able to read it because it's still working. Out of 10 answers for all these questions. Okay, now if I'll go with this, and how can I apply for personal role? I'm sorry, as an AI language model, I am not able to provide the specific guidance on applying for personal loan. Similarly, this giving of vague answers. uh, what is the difference between credit card and debit card? A credit card and debit card, two type of credit card, two type of cards that are used to make purchase or withdraw money from bank. Not again. What happens if I only pay minimum amount due on credit card? I'm sorry, but as an AI language model, it goes against my programming to provide guidance or advice for financial things. So you can see that it's giving I am sorry for everything. And best most of the answers like vague answers, no use, I am sorry again. And then improving your credit card, this, I am sorry again. So this is why we need a fine tuning is required. So we have the base answers as well. Let me see. So base answers is are good, we have there. Okay, and just close it. And now execute the base. We'll just save the base answers. Now see, we have a base answers here as a JSON, so that we can compare at the end. Let's see, and then we'll go. We'll download the stage one adapter. You see, we don't have any model over here. We have downloaded. If it is failing from Hugging Face, then we'll have a upload it from here and we'll execute again. So let's see whether it is downloaded from Hugging Face or not. So it's downloading from Hugging Face, downloaded adapter from Hugging Face. This is the stage 1 adapter. And similarly, then we'll do the load the adapter and attach to the fresh LoRa weights. We load the adapter with fast language model for pre-trained, then immediately get prefect model to attach new set of LoRa adapter on top. Why do we need the LoRa adapter? The stage 1 adapter already contains A and B matrices domain for SFT. We need additional adapter capacity to learn Qwen. Uh, get perfect model adds a fresh randomly initialized sets, same rank alpha dropout as stage 1. So stage 1 adapter, general and finance one. The stage 2 model goal is basically all of above plus Qwen, what we produce here basically. Let me now, it is taking the stage 1 model. So stage 1 adapter is true, it will go inside it. Already have a LoRa adapter, we'll skip this step. And then we have load instruction sets. So each line of JSON like this we have in Qwen, instruction and response. This is for git clone, no use because my GitHub library is different. And then we'll go and we have the data instruction, just load the data. So data has been loaded, all 104 questions have been loaded. So it's a chat template kind of thing. Now we go and tokenizing those. Apply chat model, let's do that. So we have asked the questions and we are just tokenizing that one. That questions, our questions we have tokenized just the similar way as we have done it in the stage 1. So here it is SFT structure stage 1, but two key differences. Basically, it is important that stage 1 we have a 57 raw paragraphs. Here we have a questions 104. There we have a 3 epochs, where here we have a 5 epochs. More pass needed instructions. Learning rate, it is same as standard LoRa, is appropriate for both, and pre-advised train batch same as same T4. And 5, why 5 epoch, why, this is the question. The instruction dataset has 104 example, small by fine tuning standard with only 3 epoch. The model may not have enough Qwen pattern to generalize across the domain. 5 epoch gives it more practice without serious risk of overlifting. We have weight decade 0.1, LoRa dropout 0.05, regularize. So let me do the training. We are doing the SFT trainer. We have all these parameters and then we'll do the training. We have an Unsloth train tokenizing and then we'll have to do that. What to watch basically when we do the training? Loss should decrease steadily. Overtraining steps with 104 sample and batch size of 16. There are 32 gradient steps for our epoch, per epoch 160 total. So healthy SFT basically loss drop to 1.5 to 2 range, down to below 1 by epoch. A loss that doesn't decrease after 2 epoch 2 suggest the training rate is too low or data, the formatting can be issues. Expected time is around 5 minutes. Let's do that. Now we are doing the training. So we have a first epoch done. The training loss is 3.79. The next steps 2.82 training loss. Next is 1.94. Another 2 supposed to run 1.61. So it is gradually decreasing as we have understand. So we'll have the model data ready. Then we have to save it again to Hugging Face and download it in local. Download is local is basically if you want it, if it's having any issues to while uploading and Hugging Face, or we lost that Hugging Face, we have downloaded here. So we have completed all, and that you can see that it's decreasing. So now let me save it. So now if I'll go here, I will be able to see SFT adapter is here, data is here, and then again first thing the download similar as stage 1. I have to download. In the meanwhile, I'll show you that we don't have anything. I think I have already shown that we don't have anything in the Hugging Face. So whilst it will push to Hugging Face, this SFT model, we will see that it is available there or not. So again, I have to paste my token, enter, and then verify token is true. And we can also do that. We don't need to ask the Hugging token directly taken from the secret, but it's I left it the choice to just to show you that this is also a way we can do that. So now we can see go back. We came back here and we see that all models here, not in our all models. Basically, we have to go to our my repository Hugging Face to see that model has been uploaded or not. Yeah. So now if I'll go, I can see my stage 1 and SFT stage 2 adapter is also uploaded here. Go back to our notebook. So we have verified its model has been uploaded. In fact, there is no need for us to check it, because if it's showing that it is there, we have to understand that it is already there. Now test the SFT model with the same questions and said, let's see the answers. Base models, what how it is giving with the verbose, hedged text book like terms sometimes, and vague answers, may ramble or list generally. But SFT model you can expect concise, direct, assistant style, correct use, EMI, SIP, TDS. These kind of answers you can expect. Let me run that. Again, we are checking again with our new model. We are checking the same questions what we have tested initially. We are testing it again to see the answers behavior. How can I apply for personal loan? Remember, base model was giving I am sorry, start with I am sorry. You can apply a personal loan submitting an application providing that what happen if I only pay the minimum amount of due on credit card. If you only pay this, there's no vague answer I am sorry start with that, because if you remember, base model was started with that kind of answers. Let me remove this part. Okay, so the answers are coming differently. What is the difference between interest and floating point rates? Fixed interest rates and are fixed for entire tenure for loan, while floating interest rates are adjust based on market conditions. So these answers are different, and it is giving different way of answers. So now it is done. Let me see if there is anything else. So what come next? Basically, we'll do that. Uh, we'll also do that next. What we have now SFT model. We'll that SFT model we will download in the DPO one. But before that, we'll also have to evaluate with the correctness of against with the base SFT answer and then this answers. We have remember we have saved the base answers and now SFT answers. So you can see the base answer was I am sorry, but I cannot assist. What that? I like that answer is what is coming. Now SIP, simple account payment, is a prepaid bill that allows you to pay for a service product installation. So you can see that the answers are very different uh, as comparative to base model. So what is the difference between fixed and floating interest rate? Fixed interest rates are rates that do not change over the time, while floating interest rate, so it's a base not means it's a as we have as we understand that this will answer base one base and comparison. It was terms sometimes missing the way text look like, textbook like, maybe remember or contact your lender, like that kind of answers was coming for base model. Now what is SIP? I am sorry, but I cannot assist with that. SIP is the answer we get. What is the difference? These answers we have the different way of answers. However, we'll have to next stage. We'll have the different kind of answers. Let's see for the DPO one. I have uploaded the DPO, preference alignment, direct performance optimization after stage 2. Now let me also upload the data, manage sessions. Okay, remove that, kill that previous session. I don't need, terminate other sessions, close. Now let me upload the data, ensure that we have to connect with T4. So it is connecting. Once it will connect, I'll upload the data. Same way, I'll not upload the SFT model what we have downloaded, but we'll upload the only data. Rest everything is already there. The good thing is, even if it is reconnecting, connecting, it is not. We have three sets of stage. For every stage we have a different notebook, so that there's a problem that we have to download every time and upload to Hugging Face. The good thing is, even though it is disconnecting and you have a break in between, so you can do that as well. Means anytime you first stage completed, even it is taking hours of that, it works. Basically you complete stage 1, next you can do that stage 2. So my it is connected already with the T4 GPU. I have created the folder and I have to upload the data. So let me upload the data. I have uploaded the data. This is JSON. Let me open it as well. So it has more concise answers, like again the similar way we have a prompt and then chosen answers like that. We'll cover it everything. So this is one we have set of 51 questions. So basically after stage 2 gives correct finance answers most of the time, but correct answer is not same as possible answers. Give incomplete answers. Sometimes you may lose interest if you exit early. So basically, like that, it is not giving any answers properly. So chosen will give you that answer. You should immediately block the card. If suppose same question, if what if I lost the card? So immediately block the card app and report it to customer care to request a replacement. Complete, safe, professional, actionable. Rejected is basically don't worry about, it will probably be fine, dismissive, unhelpful. DPO loss pushes model toward chosen, away from rejected. So this is the formula for the DPO loss function. So these are the examples of rejection. Just ask someone else, just don't report some income. Nobody will check. Once a check is issued, there is no way to stop it. SFT versus DPO. Key differences. What we have it is stage 2, instruction and response, prompt chosen rejected triple. I think I have missed the rejected message. However, it is there in that thing as well. Let me go back. Chosen and then we have a rejected. So it is also having a rejected one. I missed that to show you. So it has that kind of answers. So let's start first installing all the libraries. This is again, maybe it will take time because it will connect, reconnect. Let's wait. Once it is done, we'll come back. I'll come back. So finally, again connected, disconnected again, and it is finally my installation done. Now let me download that SFT adapter, which is again we have this is in Hugging Face, the similar way what we have done it in stage 2. So let's see, grant access for Hugging Face, and it is downloading from Hugging Face. Again, the SFT model. Now this is done, and then there are some questions. This is for your reference. Expected here is basically we why are two new adapters needed for DPO. In DPO, we need two roles: reference model reference, the fixed SFT policy represent what we started from. Policy model, what we are actively training, starts identical to reference, then diverges. The DPO loss measure how much the policy has moved relative to the reference. Unsloth handles the ele- elegantly with reference model none. It uses the frozen base weight as the reference and the LoRA adapter weight as the trainable policy. This means no second copy of the model VRAM, the frozen base reference, the trainable LoRa policy. Lower training rate than SFT. Why? DPO updates are more sensitive than SFT update. A high learning rates can cause the model to collapse. Forget the SFT behavior while chasing the preference signal. Okay, expected output from this configuration of the LoRa adaptable. Basically, trainable parameters basically around this much, and trainable is 1.75%, same as LoRa config. Let me do the fast language model and then do the tokenization and then loading this parameter. Same thing, we are loading the it will basically downloading that. We can see that it's while it is there, it will have the data for Unsloth here. Let complete. Let me refresh. You can see that Unsloth model is downloading. Load the preference data set. What should I do if my credit card is lost? We have this dataset which I have showed. It is in prompt, chosen, and rejected. So we have taken it file from the. We have already uploaded this file. Let me do this. All 51 questions will is uploaded. Now we do the DPO trainer aspect. This to getting all prompt, chosen, rejection. Just mapping it. It's just a chunking, tokenizing basically. So these are the parameters for DPO specific. Let me train it. We have these parameters which we have discussed earlier. Tokenizing the train data set, and then we'll have a training that will completed. Now let's done this will take some time. Training will take some time. Now we have 3 epoch here. I think I have mentioned above. Let's see the answers. Training, loss, reward chosen, reward rejected, rewards accuracy, reward margin, chosen rejected, log PS. All these are there. Let's complete these 3 trainings sets for 51. Total 21 steps. So we have the data. We can see the final outcome. Training loss is 0.299, which is we need it. So you can see that it's drastically reduced. So final deliverable, basically we have to, if we see that stage 1 we have tested with the base model, stage 2 we have tested, we have done the training with LoRA, and then stage 2 we have done with the instruct model, and then also compared the answers with the base answers. Now we are doing this with the stage 3, and we have again this model name, and we will also upload this one. So now we have to save this model. This model name is finance DPO adapter. Same way, if I'll see it here, I'll be able to get this finance DPO adapter. Same way, let me download it, and then we have again Hugging Face Hub installation. Get the token, enter, verify token, true, then it will upload to my Hugging Face. After upload, we'll go back to our Hugging Face again and then check. This is, we have 2 adapters, just refresh, and we'll be able to see all 3 models here. We have a DPO, we have a SFT, we have a stage 1. Let's go back to our notebook. Now we have to evaluate with the same question. What is the difference between basically DPO and SFT model? DPO model, correct core fact, full picture, cause, consequences, next step. Safety, rarely alarm, flag, risk. Basically DPO will risk the alarm. So this is all together it's more useful. We'll copy the answers to the DPO model answer. Let's see if I have that. Not now. Let me refresh. So it will be, once we'll do that, we'll save it here. Now it is not there. Once we'll have this, it will be uploaded in the next one. So it is running. Once we'll do the refresh, we also can see that zip model here. So it is, all 10 questions are running now and their answers. We'll evaluate the answers later. What is SIP? SIP is an accountable, this is this, and I cannot read it immediately. So this is basically how can I apply for reimbursement question. We can ask the answers, generate answers, and print answers. The same thing we'll do it in the next one. Let it complete. Is it completed? Is still running. Completed. We should have now that DPO model answers JSON file. Now go back to the next cell. Now we have a generate answers. And what questions we are asking? Question is how can I apply for reimbursement? Generate answers. We'll have the answers question and answer here. So answer, how can I apply for reimbursement? What is the difference? You can apply reimbursement by providing proof of your medical expenses such as receipt and all these things. And what is the difference between credit card and debit card? A credit card allows you to borrow money against your credit limit. A credit card offers this answers are coming, which is more relevant than the previous one. So that's all from my side. If you like the video, then please like, share, and subscribe. This will really motivate me, and I'll keep building this kind of videos. So we can again go through. We'll have any, or if you need any other any other preference or anything, just put in the comment box, or connect with me over the LinkedIn. Thank you very much.